Welcome to today's webinar. My name is Jeffrey Palermo, and I'll be your host for today. So we have a phenomenal crowd today. Lots of interest. Midsummer webinar, and we're going to be talking about Blazor MVC. I've actually got a lot to cover, so I'm going to dive straight into it. I see just from looking at some of the names on the list who are here today, I can see some past attendees at previous webinars who've asked really intelligent questions, along with a lot of new names. Look forward to getting to know you guys better. So there's the chat window, there's the Q&A. If you have a question, I'm pretty good at answering questions during, but I'll make sure that we don't end this without everybody's question answered. So you can put those questions in the Q&A window in the software, and make sure to open up the chat window. There's a few links that I'm going to talk about. Those will be dropped into the chat as we go along. So let's get right into it. For our sponsor of today's webinar, ClearMeasure is a software architecture company that's empowering software delivery, enabling in-house .NET teams to be self-sufficient, able to move fast, deliver quality, and to run your systems with confidence. So as an architecture company, we try to make your in-house team more capable so that you don't have to outsource projects, because we know that you want to do more in-house. And so that's really exciting. Another resource, if you are not a listener, I host the Azure DevOps podcast. You can look in any of the podcast directories, just search for Azure or DevOps. It comes up in the top 5 typically. And we're just past show number 200. And for people who are interested in Blazor, I recently interviewed Steve Sanderson, the creator of the Blazor idea, as well as Daniel Roth, who's the product manager overall of ASP.NET at the moment, including Blazor. So if you're not a listener, go ahead and check out that. Also, my latest book is .NET DevOps for Azure. And if anyone is interested in a complimentary electronic copy of that book, just send me an email. I'll put the email on the screen at the end as well, Jeffrey@clearmeasure.com. And you can also buy it anywhere print books are sold. And so let's jump right into MVC, Blazor MVC for Blazor. And I want to talk about why I care. Way back 13 years, maybe more than that, 2008, 2009, actually in 2007, Microsoft created the first kind of concept of ASP.NET MVC, when all web applications were kind of page-based applications, and sprinkle in some jQuery, a little bit of JavaScript before the industry kind of moved to more rich applications in the browser. And so I wrote a series of books, actually 3 different editions of this book, ASP.NET MVC in Action. And back then I was, and I still am, really concerned about what I've seen with so many teams. And I've been working with development teams for so long that I see things that happen over and over again. And one of the things that happens over and over again is that the user interface of applications gets to be just a big jumbled mess. And there's logic, there's code to make things look proper. And then there's code for a screen to have a certain behavior. And when those 2 different types of code are in the same source file, it just leads to a big jumbled mess. And the MVC pattern, model view controller pattern, is not new. It goes back to the 70s. It's traversed a number of languages and frameworks and computing paradigms. So it's not a new idea, but I've seen that a lot of people don't know how to apply it to the current platform and your current application. So I wrote this book way back then because I was really excited that Microsoft was making that a first-class pattern, kind of right out of the box with the file, new project templates. And that's, I've cared, ever since. And I've done tons of speaking on the topic in a lot of forms or fashion. But with Blazor becoming kind of the new super popular application type, this is relevant once more, because the out-of-the-box pattern puts controlling logic or screen behavior, puts that kind of code into the same source file as code that makes the screen look a certain way. And you can use code behind or whatnot, but it ends up being in the same object, which is running at runtime, and that makes a difference as well. So way back when MVC was coming out, I was one of the co-founders along with Eric Hexter on the MVC Contrib project that added on a whole bunch of functionality onto ASP.NET MVC, and that was fun. And so just earlier this past year, I decided, you know what, I'm gonna launch a new open source project called BlazorMVC. So you can find that on NuGet.org. In Visual Studio, you can go to Manage Packages and you can pull up Blazor and take a look at it. It's available right here. And of course, it's newer. I mean, it's what, just half a year old, maybe 7 months, 8 months. And so you can pull it down. Anything that uses .NET Standard 2.1, so .NET 5, .NET 6. There's lots of samples, and I'll do a demo. But you can check that out on NuGet.org. So let's dive into this concept and why we need it, and then what it looks like. So MVC stands for Model View Controller, and in this pattern, we are the canonical definition right here on the screen. I don't need to read it to you, but I will. The user input, the modeling of the external world, and the visual feedback to the user are explicitly separated and handled by 3 types of object, not just code file, but objects, each specialized for its task. The view manages the graphical output to the portion of the display that's allocated to its application. Again, this is the old definition, okay? So it's not like the pattern has to change. The controller interprets the mouse and keyboard. The controller interprets the input from the user and then commands the model or the view to change as appropriate. So the controller's in charge. And finally, the model manages the behavior of the data of the application domain, responds to requests for information about its state, and responds to instructions to change its state. So the model, sometimes you think of the model as, oh, the rest from the user interface, the model is the rest of the application. But if you have a domain model properly factored, then you have aggregate routes that you're interacting with, and then you're just kind of sending the aggregate routes to domain services for persistence, to save to a database, to get from a database, things like that. All right, so this is what the code looks like when you separate. And I'm not going to go into what is Blazor, because I'm just going to assume, and if it's not the case, I'd be more than happy to spend more time with any of you who have not seen Blazor, but I'm going to assume that everyone has at least done a file new Blazor project. All right, so the counter controller is in the default template. And this is what it looks like to separate that little bit of logic from controller logic to view. So this is what it looks like when you use BlazorMVC. You have 2 files. One is the view, and by the way, both of these, just because of the inheritance hierarchy, both of these ultimately inherit from component base. So both of these are Blazor components, and they have the same, and they all the lifecycle events you can take advantage of. They're both Blazor components. But the view, you can see all it does is have a little bit of markup to output something, and it funnels the callback on the button click to on increment. That is an action property, which basically is a callback. It's a closure to a method that the controller sets. So the controller on view initialized is going to set the on increment callback action to the controller's method, increment count. And then of course we have model and time as 2 other properties that can be set. All right. Time is not even used, but I'm going to show an additional pattern in a minute that will use time, but just ignore time for now. The model is just basically an integer. Okay. So if I hit the button, it's going to increment. All right. Now, why do we even really need this? Isn't the Blazor pattern fine on its own? Yeah, people are doing amazing things with the Blazor framework as it is, and it's great. But when you find yourself looking at a code file, looking at a Blazor component and seeing, oh, shoot, there's a lot going on in here. I'm having a hard time understanding what's going on. That means that there's an architectural element that is missing that is trying to emerge. And a lot of times that architectural element is separation of the different types of code that you see in that file. And of course, from decades of user interface work, we understand that it's really useful to separate code in the user interface into two types. One is the view code and the other is the controller code. And I'm hoping that that most of you are already in the habit of separating model code from the UI, and I've already factored that out. But I'm pulling up this Blazing Pizza, which is an example Blazor application, and I'm gonna actually go over to one of the files on GitHub, Blazing Pizza. It's Brady Gaster is the maintainer of this, and it's a good sample project to show Blazor. But when I look at and this is a very simple application, and just pull up the configure pizza dialog component, right? And you look at this, and in the very simple cases, we got to scroll down a little bit, but in view code for screens that have a lot of different pieces, the markup, you're going to scroll, no big deal. All right. And at the bottom is where we have behavior, and we have some if statements here, some commands here. And this is in the simplest case. This is only going to grow from here. It's only going to grow from here. And we have a pizza count 6. There's a little bit of logic embedded there. And these are the simple cases. In the real world, you have files that go on for days, and it just gets worse from here. So when I look at that, I think the model, you just from default, my recommendation just almost all the time is to separate it out. All right. Okay, here's the URLs, and so just look for Brady Gaster, Blazing Pizza on GitHub. You can see all that code. And I'm not picking on Brady. Brady's a good friend of mine, and it's a great sample. I could have picked any Blazor sample out there, and it's just inherent, in my opinion. The applications that you work on are going to get a lot more complex, and the logic's all going to run together. So how do we separate it? All right. And if I haven't convinced you that this is even a useful thing to do, then you'll probably disconnect from the webinar anyway. But for those that are still with me, this is how we do it, and this is how we think of it. Okay. So there's a few scenarios that we're gonna empower. The first one is if we want a screen layout that's different based on something in the user environment where we literally need to choose a different view. CSS can do some great things with responsive layout and all that, but in certain cases, we need to look at what's going on, who the user is, what the environment is, and just flat out choose a different view file, a different Razor component to be the view. And so in this case, if we have our controller executing first, and the controller gets an opportunity to evaluate the environment and then choose which view to load. In this case on the screen, maybe we want a mobile view, or maybe we want a desktop view, because for mobile view, maybe we want to use mobile Blazor bindings. Or we want to have it completely different as opposed to just a smaller version of it. Okay. In other cases, we may want the screen layout to be substantially different based on the data that's coming through. And in this example, actually, this is from the auction application that Microsoft has in their .NET Showcase. It's one of our clients, and we were able to submit it to the .NET Showcase. And you can either search for Clear Measure in the .NET Showcase or ShowWorks. And this is for county fairs. And there's different types of ways to auction an animal. Some of them are where the buyer takes home the animal, and others are where the exhibitor is going to keep the animal, but the people who show up to the auction contribute what are called add-ons in order to help this young child's agricultural education. And so the data fields are very different based on what is coming back. And in this case, you can have your view know about all the different types of records that are coming back and then just hide it. But then you have a view that has to know about every single type of record that could be displayed on this screen when you're showing it in this fashion. And so instead, the controller can choose a specialized view based on the record type, and then that view is perfectly situated to display based on the data. All right, and then finally, parent-child and layout interaction. When we have a screen, you have a layout which has navigation and whatnot, and then you have maybe the main screen, and invariably that screen is going to be broken up into subcomponents or child components. Those components in and of themselves are typically broken down into child components, and so you have a big hierarchy. And there's communication that you want to happen, and to have a page have a reference to the layout or pass a reference to itself to a child, which passes a reference to the child, so that you can have .NET events or method callbacks traverse up and down the hierarchy. That method falls on its face. And so we need the ability for communication across every component that's active on a particular screen. And so when we think about communication between parts of the screen, that's not a view responsibility. Okay. That really is code that's deciding what to do. Something happens on one side of the screen, and something on the other side of the screen needs to respond and decide what to do. The deciding code, that's controller code. View code is just, hey, once we have decided, I know how to make it look like it should. All right. And then finally, I want to look at the scenario one-to-many UI events. And that is where, instead of telling another part of the screen, hey, you need to do something, or you need to, load some data so I can show you on the screen, we also need to have notifications. If you think about just events where someone clicks or someone selects a particular item, and all the other components on the screen need to be aware that something got selected. The component that is sending the event doesn't know if anybody is going to handle that event, going to care about that event. It just fires the event. And there needs to be a way of routing these events to different places on the screen. And so when we have a layer of controllers for each individual part of the screen that are wired together with a notification pattern, then we can handle that. And the views, again, all the views don't really care that they're being used in a composed screen. All they care about is their little section and what it should look like. Okay. Some of you probably have also heard of the model view presenter pattern. And this pattern was actually really popular in the .NET space with WinForms. And it was also gained some popularity with web forms. Those frameworks just created the view first. There was no way around it. The framework itself created the view first. And so model view presenter allowed a method to where right at the beginning, before the view really did anything, it created a presenter class and then delegated to the presenter class all of its events so that the presenter could then make all the decisions. And that did allow the industry, and I did a lot of model view presenter pattern with web forms and WinForms as well. That pattern allowed the separation, but the view object made it to the call stack before the presenter object. So the scenarios where the presenter looked at something and said, oh, I want to use a different view. Well, too bad, because you were kind of owned by the view that constructed you. All right. Actually, some of you probably also heard of MVVM, model view model, which had some popularity with WPF and Xamarin. MVVM is very similar to model view presenter in the fact that the view gets on the call stack first and then delegates to another class in that pattern called the view model, which made the decision. So in my view, it's kind of the same pattern. It ended up with two names because presenter is kind of synonymous with view model. When I look at how each one was implemented and which one came first and which one got onto the call stack first versus second, presenter and view model have the same characteristics. if you just look at them. So a lot of similarities there. All right, I just talked about that. Yeah, very popular in Xamarin. I included that URL there. Okay, so we'll get to a code demo really quick here, but I just wanted to just cover one more sequence here with the controller. So Blazor has on initialized and some other events. And so what we're going to do, what we're going to couple controllers with is an application-wide bus pattern. And if anyone has used a library called Mediator, then you're used to this concept of a bus. If you've ever used Azure Service Bus, where you send lots of different types of objects down the same channel and they get routed to different handler code, you're familiar with the concept of a bus. It's a really old pattern, and it's where lots of objects can subscribe or register interest in the bus, and then other people that know about the bus only can send an object. We tend to call it a message as far as the pattern goes. Send an object into the bus, and then the bus basically lets every other object that's registered with it get a little sniff at that object to basically ask the question, hey, do you know how to handle this object? Do you know what this object is? Do you know what this object is? Would you like this object? And by convention, Greg Young, who actually recently been on the Azure DevOps podcast, there's other people, but he's done a lot of speaking and training on CQRS, command query response segregation. And he advocates for separating types of messages into 3 different categories. One is a command, one is a query, and one is an event. And I like that method, because a command is it's an object. Think of a DTO. And by the way, the new C# record types, perfect for these types of objects. It represents a request for the application to do something, and the command may have a return value, but not necessarily. And so when it gets put down the bus knows that the first object that's registered on the bus, the first handler to say, I've got this one, wins, because commands can only be handled by one time. A query is a command that must return data. It is a request for data, and it can only have one handler. So the first one to say, I got this, wins. And then an event has no return, because it doesn't even need to have a handler. And the bus knows that for an event, the bus is going to give the opportunity for any number of objects to receive the event. So it's a one-to-many, and there's no return value. So those are the types. All right, let's look at the code. We're going to start, and I'm going to switch over to Visual Studio. And this code, by the way, it is in GitHub. If you go to nuget.org and search for BlazorMVC, there's a link to the project in GitHub, so you can download this exact solution. I mean, this is BlazorMVC with and some embedded samples. So I'm going to show you the WebAssembly.NET 6 sample. The others just have a little differences in Blazor, but as far as the use of the framework, it's the same. So let's see. We'll start just how the application starts up. So every Blazor component has been separated into a controller and a view. And if we look at the packages, it's not a package in this project because we actually have the BlazorMVC as a project right here. It's not that big. I'm not going to go through the exact code, but it doesn't even have a nested namespace. It literally is not that big. So, look in it and look through how it's implemented and have fun. But let's look at the usage first. It starts up. By the way, you know what? I am going to start up the application, just run it so you can see kind of what it does. And it's running. All right, running right there. That's good. And the browser that it opened. Oh, it actually opened here. All right. So if I go home, What can you do that? Add another child. This is one of the things we'll explore. And notice this. So we have some complex different behavior where I'm actually embedding multiple instances of the counter component. And each one, look, is in fact very independent, but then each one is also updating a time element, which you saw. And so we have some kind of eventing going on, and all of them are doing it independently. And I want you to watch through the code that this is a parent page, and then each of these counter controllers are children. I want you to see that this parent is not individually telling all of these children that it should update time. That's really important. Of course, we have the regular counter and we have that, but counter itself has some type of changes going on. So we'll look at that. And then fetch data. This is in the default template. But if I select, let's say, Balmy and click on that, now we have another child popping up. You see Balmy based on that. And we have this time element again that's updating individually. So if I choose bracing and I click on freezing, I click on chilly, it updates right there. All right. So that's the application. Let's look at the different elements and pay special attention to this updating basically every second. All right. So we have app controller. Actually, the first one is we're going to add a IUI bus as a dependency, and we're going to create the MVC bus, which is part of the Blazor MVC library. And in this case, we're just not even going to mess with the logging. But in your application, you're going to want to redirect logging somewhere, and that's great. Okay. So we have that MVC bus and our app controller. Let me go into app controller right down here. App controller inherits from controller component base. So in Blazor MVC, there's two subclasses that both inherit from controller base from Blazor, and one's controller component base and one is view component base. And so those are the two base classes you'll use. And so the controller logic, all we do here is add an additional child controller. And in this case, we don't have to use markup to embed a controller. We use code to embed a controller. And we use a base class method called append render fragment. Blazor doesn't have a controls.add or a child controls.add type of method like the previous frameworks had. And the concept of subcontrollers never made it to ASP.NET MVC. There was kind of like HTML.action that came from the view. And so MVC contrib, that open source library, had a pattern for subcontrollers where a controller could decide that it needed a child, and you didn't have to have the view decide. All right. So we're going to embed this heartbeat controller. Let's look at what this is. Heartbeat controller right here. Notice that heartbeat controller inherits from MVC component base. Actually, I left out one of the inheritance hierarchy in this case. Let me just show you this code. All right. So controller component base inherits from MVC controller base. I'll dive into here, which inherits from the Microsoft component base. Okay. And you can look at the code. I'm not going to, a lot of this is just logging and making sure that all the events are available. And the big intelligence here is how to use Blazor's render fragments to embed the view into the controller and how to modify building the render tree. That's a little bit tricky. You don't want to have that in your application code. That's why we put it in the library. Okay, so heartbeat controller inherits from one level down base class. Why? Because it doesn't have a view. It doesn't care about a view. In this case, for this responsibility, we don't need any markup. We need a component to be in the screen, alive in the screen, but there's no need to have anything visual. And therefore, we're not placing it in a certain spot. It just has to be somewhere in the render tree doing something. And what is this doing? It's just doing a timer. It's doing a timer for 1 second, which is 1,000 milliseconds. And all it's doing when it's invoked is bus.notify. Bus has few methods. One is notify, and the other is get listeners. Get listeners handles queries or commands, because we can get the listeners, which gives us iListener of T array, and then the bus can iterate through. Okay. All right. But don't confuse this style of bus with the mediator implementation of a bus. This pattern right here is not for handlers to save data to a database. This is a user interface bus. This is only for the UI. Okay, look, and the interface UI bus. This is only a bus between all the components that are alive on a particular screen. So don't get it confused with the different type of bus that you would put on handlers to actually save to a database, go to web services, talk to other applications. This bus is for a particular screen inside the user interface of the application. All right. So notify is primarily the thing that's important for this implementation. That's why we don't have a bus.send. All right. But either way, it's going to notify with a new application heartbeat with the current time every 1 second. Okay. So that means any component can listen for what event? Application heartbeat. All right. So this is a controller with no view. That's one sample. Let me close that. All right. And app controller. App controller declares its view type. So let's control B. Let's go into view, which is down here. And so this is the view part of the application view, which has the markup. Okay. Pretty simple. And because of the way the framework does it, the view declares its default layout, which is the component for the layout. Now, we factored the layout into a controller and a view. And so let's look here. We have main layout controller. The controller always comes first. And I've commented this out. You can add this back just to get some more layout, but I left this in the sample. So pretend this isn't there. And of course, this type of controller inherits from the layout controller component base, which is specifically for layouts, and has a main layout view. If you want to put some logic inside your layout controller for behavior, and you can do that by just using one of the regular Blazor events. No big deal. Okay, so main layout view, this is the markup. Okay, and for the example, if the layout wants to declare any number of places to put additional components, then this is the pattern that you use, render fragment. So body is already there for you, but if you want to have any number of them, they can go there, and that's the pattern that you use. All right, so that's how the layout happens. Let's come back to app controller. All right, so now we have the app controller. We're going to start the app up, and then we're going to go to routing. Okay. Yeah, the rest is just standard. So if we go to the counter controller, first thing you'll know, well, let me show you counter view and highlight. At the top, there is no app page directive, okay? Because counter controller has it. Now, there's no at page because in reality, it compiles down to a class with a route attribute. So this is the same thing, but this controller now owns the concept of its route. And so we put that on the controller because that's a decision. That's behavior, all right? Controller component base, counter view, that's all it takes to make counter view the default view for the counter controller. And then you see these are regular Blazor methods, and there is a handle for application heartbeat. Why is handle there? How does it get? That's where this iListener of application heartbeat is. Okay, iListener, that's all it takes. However, we do need to register counter controller with the bus. So where does that happen? We are going to go, just so you know, bus is part of the framework. We're going to go down again and look at, no, it's not here. Look at MVC component base. Right here, we have a property that gets injected that is IUI bus. And then at the very beginning of the life cycle, right here on initialized, we call bus.register this. Okay. So we're using the built-in dependency resolution, the I services collection. And because we have a hierarchy, we have a property where if I was to say base.bus, boom, it's there. It's injected, property injection. And I can get listeners of a certain type, but most of the time I'm just going to say notify. And I'm going to notify of a certain class. Okay. So that's how any controller can notify any other controller that's alive on that particular page just by saying bus.notify. So we don't have to have parents talking to a child, which is talking to another child, by embedding a UI bus, a user interface bus, and having it available to every controller. All any controller has to have is say bus.notify a particular object of whatever you want, and literally every other controller that's on the call stack that's alive on that particular page is going to get a chance to have its handle method called if it just implements the interface for that particular type. All right, so that's important. Now let's go down to the fetch data controller. I've looked at counter controller enough. Let's see, home. Yeah, fetch data controller. Bing. Okay. Fetch data controller is right. No, fetch data controller. This is the parent. All right. And if you're familiar with the application template, you know that we get from JSON. And in my opinion, no user interface class should be calling outside of the application to another computer. This is sample code. Even this code should be part of your model or a domain service. All right, but either way, on view forecasted day selected. All right, so I added this. Yeah, I added this on the first column. On click of this forecast day selected forecast, and that is going to be an action callback of weather forecast. And so if we go back, we see that we have set the action view.callback equals this method. Okay, so when I click, we're going to save off the selected forecast. We're going to notify that there was a forecast selected for anybody else. Then we are going to effectively create a Blazor component right here. Fragment Builder is part of BlazorMVC, and it allows you to pass it. This is another little bit of complicated Blazor code. It allows you to pass in the type of a Blazor component, in this case, our controller, because controllers are Blazor components. And we're going to get the render fragment and essentially set it here in this part of the child. And so this is a way to really easily create a Blazor component, pass in, and pass in, whatever you want to pass in, the selected forecast. And of course, forecast day is part of forecast day controller. And forecast day pane, again, is in the view. So let me show you that. Forecast day pane, and we are displaying it right there. Okay, so that's that. And then forecast day controller, we're creating it. And again, it's a controller component base. It doesn't have a route attribute because it's not meant to own a page. It has a forecast day view. It has a property that we just set called forecast day. And we're basically setting a property on the view. Notice that this also has iListener of heartbeat. And so we're just setting that. And so forecast day view, very simple. The forecast day view of the summary, and then last heartbeat timestamp, which is getting updated all the time. So we go back here, click on it, freezing, and now it's updating. Now let's go to this add another child. This, I'm clicking, see the scroll bar, see how many I click, and they're all independent. Everyone is independent because of this framework. So let's go and look at that. All right, so inside index, all right, that's the index page. Here's the button for add another counter, and we're just calling this method, okay? All right, there we go. And by the way, the loop is however many we had, and fragments is a list of render fragment. In Blazor, you have to if you're familiar with past frameworks, WinForms, WPF, ASP.NET MVC, just better, been this concept of controls or elements. So translate in your head, when you see render fragment, think child controls, think child elements. Okay, just do that translation in your head. Render fragment is a child control to this one. Okay, or it's just a control and you can use them as children. All right, so we have render fragment, child controls or child components, and we're going to add a new one. So fragments.add, or you're going to use the same one, fragment builder, get render fragment. This, I mean, this could be translated to say, just in your head, you could, if you're familiar with past frameworks, think this dot controls dot add. Okay. All right. And so render fragment counter controller, and it's going to be a brand new one that gets constructed by the Blazor framework. And every time I click, it's going to be new one. That's it. Every other behavior is part of counter controller. The counter controller, through its base class, is registering itself with the UI bus and is initializing itself with the current count, is handling its own event application heartbeat events, and is its own thing. And it doesn't care about its parent. Literally, the parent didn't pass in any parameters to it. So it, as it's living, doesn't really know who its parent is and doesn't care. Whereas back on fetch data, this one, because it did receive something from its parent, has a method of calling back directly if that's appropriate, but still it's depending on what you want to do. And then add another child. And in the same way, because you have added the child, and you have kept it in a collection, if you wanted to remove the child, you have it in a collection. So list of render fragment dot remove. Simple as that. Okay. All right. So that is walkthrough of the code. You don't have to know how the guts of Blazor MVC work or all the weird stuff with render fragments. You can just go and download it now. A question: do we have a Maui example in there? No, there's not. There will be soon, but there's nothing there's nothing Maui specific. There's nothing web specific. There's nothing Blazor server side specific, and there's nothing WebAssembly specific in Blazor MVC. If the Blazor if the Blazor component is able to run in a certain place, then you can use Blazor MVC to separate the controller behaviors out of that component and the view behavior out of that component. So because Blazor does work, the Blazor component model works in Maui, Blazor MVC will work just fine in Maui. Its only dependency is .NET Standard 2.1, which Maui supports. I have plans to add a Maui sample. By the way, if anyone has the hankering to send a pull request with a Maui sample, I would welcome it. Love to give you credit if any of you want to contribute that sample. But the only dependency for this is that the Blazor component model work in that application type. And we know that Blazor is being adapted for lots and lots more application types. We had another customer that they needed to do a new Windows system tray icon. It's a pretty simple application just to be able to sit resident running on a Windows computer and interact with the Windows Action Center to send notifications to the user and be able to do some kind of backend stuff. And the only screens that it had were, just some status and be able to see what was going on. And Blazor WPF worked amazingly well as a system tray, as a native system tray application on Windows 10 and 11. That application did use Blazor MVC, worked just fine because it's just Blazor components. So if the Blazor component model works in a particular area, then BlazorMVC will work for you. All right. I think I'm glad that I saw this. It's in the chat and it's confirmation that the controller returns a view that is creating controllers, which then returns views. That's not what's happening. A view in this model, a view never creates a controller. Okay. Only controller, that's behavior. Only a controller will do that. Let me walk you through that again. Because I think what we're talking about is here, we're at another child where we're actually creating the controller. So let's walk through the code again. We have index. You know what? I just realized this index page is a page that I did not separate into a controller and view, because this right here is controller logic. You see, this index was not factored into controller and view. I remember the mindset I was in when I created this. It was because I wanted to demonstrate that you didn't have to go all in. You didn't have to separate every single Blazor component into a controller view pair. You could do it just for one. So if you have some really, really trivial Blazor components that you're not going to get any kind of return on investment by splitting them out, no big deal, whatever, your choice. And so I think I wanted to demonstrate that you could do that. But this really is controller logic. And so the controller is going to do that. But on fetch day controller, see, this controller is actually creating the child controller. And then we're taking the child controller and we're setting that controller to the forecast day pane because it's a render fragment. All right. And the forecast day controller itself is a container around its view. The controller doesn't have any visual elements, but the controller makes as its child on the call stack its view. So it wraps its view. The view has visual elements. And so all of the visual element of the controller come from its view. So I hope that helps. All right. And all right, so to review as we close up, MVC is a really old, reliable pattern. I recommend that you use it for complex screens, dynamically selected views, where you have to have intra-screen communication and when you have to build up screens dynamically. And the controllers should be the ones in charge. The controllers make decisions. The controllers interpret the user action. Yes, the view has a button that a user clicks, but the view doesn't know why the user clicked. The view doesn't know what should happen when the user clicks. So all the view should do is just kind of funnel that back to its controller. Actually, the view doesn't even know that its controller exists. That's super important with MVC. Views don't know about controllers. Controllers know about views. So the view just has a callback, an action property, which is a callback. So the view is just saying, hey, I'm going to invoke my action. Whatever happens, happens. I don't care, dude. The controller is going to get called because the controller set the pointer to the method that's going to be invoked. All right. All right. Finally, I'll leave this up. I love answering questions. Send me an email. If you want a free electronic copy of my book, go for it. I'll address this question, Nicholas. The sample has controllers spread out through the file hierarchy. Would it be good to put them in a folder? Absolutely. Go for it. You're in charge. Samples are always tricky. You want to make them simple enough to where everything is visible. You don't want to have too much nesting because then things are hidden. But in your own application, absolutely. You don't want just a jumble of classes. You want to organize your code as appropriate for your application. So I think to answer your question, yes, absolutely. And then another question, is there any change to the MVC pattern, whether Blazor is client side or server side? No. And I won't go through it directly, but if you go to the code, literally beside here is a Blazor server side with .NET 6. And you can see You can see all the same. Well, I didn't put it in that sample, but you can see it works the same. It works the same. The only difference is Blazor server side. But as far as how you separate controllers from views, nope, no change, no change. All right. Well, thank you so much. I think I got through the questions as well as in line with the questions that came through during the presentation. So thank you all so much. I appreciate it. Send me an email with any questions that you have, and stay tuned for the next webinar. And thank you so much for spending the time. And if you have any requests for a topic that we should do on a webinar, hey, send those over as well. All right. And I'll always distribute in the chat. You can see my email. You can see my phone number. Give me a call. It's all good. I love talking with programmers. Okay. And question that came: do you have a video or sample showing migrating a traditional Blazor app to Blazor MVC? I actually don't have a video of that transition, but hopefully the samples that are in the Blazor MVC GitHub repository show how the default out of the box project template is split. So that, and that's small enough to where you can see the before and after, because it does go off of the default template. So hope that's helpful, but I don't have a specific video of that one. All right, I think that's all the questions. Thank you so much. Have a great day. God bless.